In this lesson, we'll learn how to calculate quartiles for ungrouped data, both with and without using formulas. Let's begin with this simple set of 10 numbers. Quartiles organize data into 3 points: a lower quartile, median or mid-quartile, an upper quartile, to divide the dataset into 4 groups. Let's begin with the simple set of 10 numbers. The data is already arranged in ascending order, which is the first step in any quartile calculation. First, let's find the quartiles without using any formulas, just logic and understanding. Since there are 10 values, we split the data into 2 halves. The lower half, the first 5 numbers are 7, 8, 9, 10, 11. The upper half, the last 5 numbers are 12, 13, 14, 17, 21. Let's begin. Q1, the first quartile, is the median of the lower half. The middle number in the lower half is 9. So Q1 equals 9. Q2, or the second quartile, is the overall median. The middle 2 numbers in the full set are 11 and 12. The average of these is 11 plus 12, divided by 2 equals 11.5. So Q2 equals 11.5. Q3, the third quartile, is the median of the upper half. The middle number in the upper half is 14, so Q3 equals 14. By the way, what if we had an odd amount of numbers in the data set? For example, this set has 9 numbers. Before finding the quartiles, we would have to first remove the median. Then we will be able to split the set into 2 equal sections like this. So in this case, Q1 would be 3 and Q2 would be 8.5. Now let's calculate the quartiles using these formulas. Note that the data has 10 values, so n equals 10. The position of the first quartile is given as n plus 1 over 4. Since there are 10 numbers in the data set, we substitute 10 for n and get 10 plus 1 over 4, which is 2.75. It's important to note that 2.75 is not the first quartile. It represents the position of the quartile. Since the position is given as a decimal, the lower quartile is not exactly the second number. It is the second number 8 plus the decimal 0.75 times the difference between the second and the number that comes immediately after. In this case, that's the third number 9. So the lower quartile is 8 plus the decimal 0.75 times 1, which is 8.75. The formula for the second quartile is same as the median. That's n plus 1 over 2, which is 5.5. So the mid-quartile is the average of the 5th and the 6th number. That's 11 and 12, respectively. Add them and divide by 2, and we get Q2 to be 11.5. The position of Q3 is given as 3 times n plus 1 over 4. Since there are 10 numbers in the data set, we substitute 10 for n and get 3 times 10 plus 1 over 4, which is 33 over 4. That's 8.25. It's important to note that 8.25 is not the upper quartile. It represents the position of the quartile. Since the position is given as a decimal, the upper quartile is not exactly the 8th number. It is the 8th number 14 plus the decimal 0.25 times the difference between the 8th and the number that comes immediately after. In this case, that's the 9th number 17, so the Q3 is 14 plus the decimal 0.25 times 3, which is 14.75. Let's compare our results. Both methods are valid. The non-formula method is simpler and commonly used in classrooms. The formula-based method provides more precise values. especially useful for statistical analysis. And that's how we calculate quartiles for ungrouped data with and without formulas. Practice with different data sets to master both methods. See you in the next lesson.